What if Earth's gravity were twice as strong? How life would adapt? Gravity isn't just a force, it's the architect of life. Every living thing on Earth, from the smallest insect to the tallest tree, has evolved under 9.8 meters per square second gravitational acceleration. But what if that number doubled? At 19.6 meters per square second, life as we know it would be unrecognizable. Would animals still sprint across open plains? Would humans be short, stocky, and built like powerlifters? And what about flight? Would birds still soar, or would evolution favor ground-hugging, armored beasts? This is not just speculation. Scientists have studied how gravity affects biology, evolution, and even intelligence. So let's push the boundaries of imagination and step into a high-gravity Earth. And before we dive in, what do you think would happen? Would humans become supermuscular? Would dinosaurs have stayed small? Drop your wildest ideas in the comments. And if you love exploring extreme scientific what-ifs, hit like and subscribe. You don't want to miss what's next. The shrinking of giants, why large animals would struggle. Nature follows strict physical rules, and one of them is the square-cube law. As an object grows larger, its volume increases faster than its surface area. In a high-gravity world, large animals would struggle to support their own weight. Elephants and giraffes? Gone. Their legs would snap under their own weight. Instead, evolution would favor short, stocky creatures with reinforced bones and powerful muscles. Dinosaurs would have stayed small. No Argentinosaurus towering at 90 tons. Instead, the dominant reptiles would look more like bulky ankylosaurs, low to the ground and heavily armored. Would humans be different? Absolutely. In a high-gravity world, humans wouldn't be 5 feet 9 inches, 175 centimeters tall. We'd be around 3 to 4 feet, 90 to 120 centimeters, built like weightlifters, with ultra-dense bones and massive leg muscles. Light-bulb, would you trade height for super strength? Imagine a world where everyone is built like a compact superhero. The evolution of movement, why speed would be a death sentence? On Earth, speed is survival. Cheetahs chase, gazelles sprint, eagles dive at 200 miles per hour. But in double gravity, movement changes completely. Running would be extremely risky. At high speeds, impact forces would be crushing. Instead of fast runners, evolution would favor slow-moving, powerful creatures. Flight? Nearly impossible. Birds, bats, and most insects would disappear, as the energy required to generate lift would be too great. The few surviving flyers would have huge wings and hyper-efficient muscles. Light-bulb, could new forms of movement evolve? Maybe ultra-powerful kangaroo-like jumping, or even muscle-powered gliding. What do you think? Bone density and muscularity, strength over everything. A stronger gravity means every living thing must resist crushing forces. Bones, muscles, and even body proportions would be re-engineered by evolution. Exoskeletons would be king. Insects, crabs, and armored arthropods would thrive under high gravity with low, compact bodies and external armor. Mammals and reptiles would bulk up. Instead of slender limbs, most animals would resemble rhinos, Komodo dragons, or armadillos, short, powerful, and heavily built. Light-bulb, would you survive in a high-gravity world? Drop a comment and tell us what kind of body you think would work best. Trees and plant life. Would forests even exist? Gravity doesn't just shape animals, it controls how plants grow. On our Earth, trees like redwoods reach over 300 feet, 90 meters, tall. But in a high-gravity world, those giants would be impossible. Forests would be low and dense. Instead of towering trees, there would be thick, short plants with powerful root systems. Leaves and branches would be stronger. High gravity would tear apart weak plant structures, leading to denser, fibrous growth. Water transport would be a problem. Trees rely on capillary action to pull water upward. Under stronger gravity, this process would be limited, meaning plants would need wider, more efficient roots. Light-bulb, would a high-gravity forest be like a dense jungle, or would plants evolve completely differently? Comment your wildest theory. Intelligence and civilization. Would humans still become advanced? Perhaps the most important question. Would intelligence still evolve? Brain size might be limited. Bigger brains require more energy and support, which might make them less favorable in a high-gravity world. Intelligent species might have compact, energy-efficient brains that rely on instinct and social structures. Technology would be different. In a high-gravity civilization, everything from architecture to vehicles would have to be reinforced to handle extreme pressure. Space travel? Almost impossible. Escaping a high-gravity planet would take twice as much energy. meaning civilizations might never develop space exploration at all. Light bulb, would an intelligent species still strive for space travel, or would they be trapped on their planet forever? What's your take? Let us know in the comments. Final thoughts. A world built for strength and survival. A high-gravity world wouldn't just change how life looks, it would redefine evolution itself. Creatures would be shorter, stronger, and possibly armored. Speed would be replaced by raw power and endurance. Flight would be nearly impossible. Forests would be short and dense. Technology and intelligence might evolve in completely different ways. The real question is, would a high-gravity Earth create a more aggressive, survival-driven civilization? Or would cooperation become the key to thriving in such a harsh world? Globe showing Europe, Africa, what do you think? Would you survive on a high-gravity Earth? Drop a comment with your wildest ideas. And if you love extreme science and speculative evolution, smash that like button and hit subscribe for more mind-expanding content. Rocket fire.